Alright, sorry I can't be here this afternoon, but we are going to go through the notes for 2.7, which are the derivatives of transcendental functions. And transcendental functions are functions that transcend algebra, so they go beyond the operations of addition, subtraction, multiplication, and division. So some examples of this are trig functions, exponential functions, log functions, and etc. So we're going to be looking at the derivatives of those types of functions. So the first thing we're going to do is look at trig, and what's going to be really key for you to know and have memorized is that the derivative of sine is cosine, and the derivative of cosine is negative sine. So whenever you're asked, I didn't put directions on these problems, I'm now realizing, if I have f of x equals 2 cosine x, and I'm asked to find the derivative, 2 is just a coefficient, it's just a number out front, so I don't really have to do anything special with that whenever I take the derivative. I'm just going to have the 2, and then the derivative of cosine is negative sine. So it's going to be 2 times negative sine x. Make sure you put those parentheses, because if you don't, it's going to look like that is 2 minus sine x, and that would be incorrect. But it's 2 times negative sine x, which is going to give you negative 2 sine x. So that would be your derivative in this case. Then, we look at number 2. We've got f of x equals sine x over 2. This looks a little bit different, but it's really just a coefficient as well, because I could write this way, 1/2 times sine x. Those two things would still be equivalent to each other. So that really is just a coefficient we're looking at there as well. So to take the derivative here, that coefficient will just stay up front, and then the derivative of sine is cosine, so we'll have 1/2 cosine x, or you may see this written back this way, cosine of x divided by 2. You could get either one of those as the answer. You'll see a few that are going to be a mixture of trig and power rule here. So whenever I see 2x minus sine x, I just take the derivative of those two pieces separately. So f prime of x here, I would just use the power rule for the 2x. The derivative of 2x is just 2. And then the derivative of sine is cosine of x. So these are for the most part going to be pretty straightforward, and you just have to have those memorized for now. We're going to learn some more rules that will make it a little trickier later, but for now it's pretty straightforward. The derivative of a to the x is one that we also have to have memorized. So we've got the derivative of a to the x is going to be a to the x times natural log of a. So a here is the base of your function. So whatever that base of the function is, it's just going to be the same thing again, and then you have to multiply it by the natural log of a. So if I look at example 4, and I'm looking for the derivative here, I didn't really put directions on any of these, but we want to find the derivative. Then to find the derivative here, I just use this formula, and I'm going to get 3 to the x, so that part just stays exactly the same, and then you multiply it by natural log of the base, which in this case is 3. As far as that y goes, there's a couple different ways you can use the notation here. You can call this y prime, like that. That indicates that you took the derivative. Another option is to write it this way, dy over dx equals 3 to the x times natural log of 3. Either one of those are acceptable there. For example 5, I've got f of x equals 5 times 1.2 to the x power. So this is an exponential function as well. This 5 right here is multiplied by a number that is being raised to a power. So it is really just a coefficient. So when I take my derivative here, that 5 is just going to sort of hang out front because we can sort of pull it on the outside. And then I'm going to take the derivative of 1.2 to the x power. The derivative of the exponential is itself, so it's going to be 1.2 to the x power, but then I've got to multiply it by natural log of the base, which is 1.2. You might see them rearrange this a little bit. They might do something like 5 natural log of 1.2 times 1.2 to the x, but it's pretty much just going to stay more or less the same for that. Now, these types of problems we don't actually see a lot in what we're asked to do. What we see a lot more is being asked to take the derivative of e to the x. And e to the x is really a special function because if we use the same rule to take the derivative of e to the x, which we can do, if we take the derivative of e to the x and we use the rule that we have right here, we would get e to the x times natural log of the base, which is e. But what makes this really special is natural log of e. The natural log of e is just 1. So since the natural log of e is just 1, the natural log of the derivative of e to the x is e to the x, which is a crazy function. This is the only one that is like this. The derivative of e to the x is e to the x. So the slope of the tangent line at any point on the graph of e to the x is the value of e to the x. So it makes this a really special function that does a lot of things mathematically that are crazy. You could just use that natural log rule here, but because e's show up so often, we just usually memorize that the derivative of e to the x is e to the x. This makes these the easiest type of derivatives that you're going to take. So, like for example, for number 6, f prime of x is just going to be 3e to the x. The derivative of e to the x is e to the x. 3 is just a coefficient, so you just get 3e to the x. And then I've got a 4x here. I do need to take the derivative of the 4x, which is just going to give me 4 in this case. So you can see that it's very simple. Just have to remember your rules. Now, this particular one for number 7 looks like a problem we don't know how to do right now, because right now we do not know how to take the derivative of e to any power except for x. We will learn it eventually, but there's some other rules we've got to learn how to do first. So this looks like a problem that I cannot do. However, right now my e to the negative x is in the bottom of that function. So if I want to get rid of negative exponents, I can move it back up to the top. If I do that, that's going to be 6e to the x. Now, I haven't taken the derivative yet, although it's not going to make a lot of difference, but this is just my original function. When I take the derivative of 6e to the x, I'm just going to get 6e to the x. It is its own derivative there. So e to the x's are some of the easiest problems that you'll see. Let's keep going. Derivatives of logarithms. So if I'm taking the derivative of a log with the base b of x, then it's going to be 1 over x times the natural log of b. So, for example, for number 8, I've got y. I could write that as dy over dx when I take the derivative, or I could call it y prime. That would be acceptable as well. And I'm just using this formula here. And the formula tells me I need to do 1 over the x multiplied by the natural log of the base. So in this case, my base is 5, so it'd be natural log of 5. Okay. 9 is only slightly more difficult. When I take the derivative of g of x right here, 6 is a coefficient, so it's going to just sort of hang out front. You don't really do anything with it. The derivative of log base 4 of x is going to be 1 over x times the natural log of the base, which is 4. So what you're going to see here, though, is they're usually going to combine that back. And so that 6 is over 1, and so it will usually look like this: 6 over x times natural log of 4. So, now, they may sometimes do something a little crazy here, and this is some log rules that you may or may not remember. So, this is fine for a free response question, but sometimes if you have something multiple choice, they may not have this answer choice there because they sometimes do this. Natural log of 4 could be broken down a little bit. And the natural log of 4 could be written as the natural log of 2 squared. And in pre-cal, we learned those special rules for logs, and we could take that 2 and we could pull it out front. And so that would be the same as 2 natural log of 2. So natural log of 4 is the same as 2 natural log of 2. If I substitute that in here, I've got x times 2 times natural log of 2. Well, everything's multiplied right here. This all is being multiplied together. So I can reduce the 6 and the 2, so that would be a 3. And that would just be a 1 right there. And they might reduce this to make it 3 over x natural log of 2. Like I said, for a free response, this first answer is perfectly fine. For a multiple choice, they might simplify it into this. Okay. Now, these are for logs with bases of that are not e. We really don't see these very much either. The one that we see most of the time is the derivative of the natural log of x. And so you might remember that the derivative of, or not the derivative, but the natural log of x is really could be written this way, log base e of x. And so if I use that rule for derivatives to take this derivative, I would get 1 over x times the natural log of e. But as we just talked about a little bit earlier with our e to the x, the natural log of e is equal to 1. So whenever I do this, this is really just going to be 1 over x. And you'll see on the next slide that is our rule for the derivative of the natural log of x. So the derivative of the natural log of x is 1 over x here. So whenever I have a problem like example 10 and I want to take the derivative, I'm going to do f prime of x equals 4 is the coefficient. It just kind of hangs out front. And the derivative of natural log of x is 1 over x. We're typically going to put that back together so that 4 is over 1, and that would end up giving us 4 over x for that. For example 11, you're going to take the derivative here, so you can call this dy dx or y prime, whichever one you prefer. Same thing for the first part as what we had for number 10. We're going to have 6 times the derivative of natural log of x is 1 over x. But for the second part, currently it looks like something I can't really do. However, I probably should have done this first. I could rewrite this with negative exponents. So instead of having a fraction here, I could move this back up to the top and give it negative exponents. So it would look like this, minus x to the negative 2. So when I take the derivative here, I want to use the power rule. Negative 2 times that negative right there gives me a positive 2. X to the, then I need to subtract 1 from my exponent. I'll get a negative 3 here. Now on a free response question, you could leave the answer like this. It would be fine. It is probably definitely not going to be the answer if it's multiple choice. If it's multiple choice, they are going to probably simplify. They, if nothing else, will probably do this. They'll make this 6 over x, and they'll probably send this negative exponent back down to the bottom and give you 2 over x to the third. There is a chance that they might even combine these to get common denominators here. If they do that, you need to multiply by x squared on the bottom for that first term, which means you would multiply by x squared on the top as well. So we'll get 6x squared plus 2 on the top, and then the denominator will be x to the third. This is the multiple choice answer you're probably going to see most of the time. But it would be fine to leave it right here for a free response question. Okay, so let's look at a few problems that are like some tangent line problems here to see what sort of stuff you will run into with this. Most of the stuff that we're doing or have already done still applies. It's just going to be a little bit messier whenever you have some logs and natural logs and e's and all of those different things. So if we're supposed to write the equation of the line tangent to the graph of f of x equals 4x minus natural log of x at x equals 1, this is an equation of a tangent line problem. For an equation of a tangent line problem, we need a point, a slope, and then we need the equation of a tangent line. So for our point, we are going to find f of 1 for this. That means we're just plugging in 1. So we got 4 times 1 minus natural log of 1. And depending on what you remember about natural logs, natural log of 1 is going to be 0. So this is going to be 4 minus 0, and we'll just get 4 for that. So our point is the point of, not 0, sorry about that. Our point is 1 is the number that we plugged in for our x, and 4 is the number that we got out. For our slope, we are first going to have to find the derivative of f of x, because the derivative gives us the slope of the tangent line. So f prime of x here is going to be, the derivative of 4x is just 4, and then we just learned the derivative of natural log of x is 1 over x. So that is our derivative. We need to know the derivative at 1, so to find the slope at x equals 1, we just plug 1 into that derivative. So we'll have f prime of 1 equals 4 minus 1 over 1, which is just 1, of course, so we'll get 3 for that. That's our slope of our line there. So finally, we're going to write our equation of the tangent line. And here is where we use our point slope form, which is y equals m, which is the slope, so that's 3, times x minus x1, our x coordinate is 1 right there, plus y1, which is 4 right there. So this would be our final answer. That one worked out pretty nicely. We had nice numbers in the answer there. So that natural log did not really cause us a lot of problems. If I remember correctly, 13 gets a little bit messier. Here, they are telling us that the line y equals mx plus b is tangent to the graph of g of x equals 3e to the x plus 2 at x equals 2. What are the values of m and b? So y equals mx plus b is our tangent line, and it wants to know the values of m and b. So it's asking us for the equation of the tangent line. It is also forcing us to give the slope and the y-intercept, which we did not really have to do on this. But by asking for m and b, it's asking us to find slope and y-intercept. But the first 3 steps are going to be just like the last problem. A little bit messier, but just like the last problem. So to get our point, we're just plugging our number, which is 2, into our function. So g of 2 is going to be 3e squared plus 2. Now the problem is this is not going to be a calculator active question, and we are not going to get to use the calculator to figure out what that decimal is. So our point is just going to have to be 2 3e squared plus 2. Alright, so this is our point that we are using. So you can see things are a little bit messy here because we don't have just a nice number like 4 like we had on the last problem. But we can work with this, it'll be okay. Our slope, to find our slope, we have to find first our derivative of g. So g prime of x is going to be, the derivative of e to the x is e to the x. So right here we just get 3e to the x. The derivative of 2 is 0, so it's going to go away there. So our derivative is just 3e to the x. Now, in this case, we only care about the derivative at x equals 2. So we need to make sure we label this here. We're going to call it g prime of 2. And we're just going to plug 2 into our derivative. So we get 3e squared. This is our slope. Once again, it's a little bit messy because we have to just leave the e there since this is not a calculator active problem. So, but we've got the pieces that we need. Now we can write our equation of our tangent. And to do that, we are going to have y equals our slope, which is 3e squared times x minus 2, plus y1, which is 3e squared plus 2. Now, if they had just asked this question like the last question, then we could just leave this and we would be done. However, they did not. They specifically said the line y equals mx plus b is tangent to the graph of g of x, and what are the values of m and b. So we could go ahead and confidently say that m equals 3e squared because m is the slope, and we know the slope is 3e squared. But to find b, we're going to have to simplify this into y equals mx plus b form. So we would have to distribute here, and we would get 3e squared times x minus 6e squared plus 3e squared plus 2. And then I can combine negative 6e squared and positive 3e squared. So I will get 3e squared x minus 3e squared plus 2. So whenever I look at this, I'm looking for the y equals mx plus b. This number right here is your m. We've already said that because that's our slope. It is multiplied by the x. And then this other stuff over here, that is your b. So we would say b equals negative 3e squared plus 2. And you know, if we had a calculator, we could just type those in and get a decimal. But of course, this was not a calculator active question, so we couldn't do that. All right. Let's look. Oh, so that is everything that we need to go over. So the last two slides on this are not problems we're going to do together, but rather some homework problems for you guys, because our book did not do a very good job of including some of these logs and exponentials with different bases. They also didn't have the tangent line problems that I was wanting to see. So I have included a few of those there. So your assignment is going to be to do page 143, 19 through 24, 35 through 38, 49 through 52, and then these 5 problems that you see on the last slide. So you have the rest of the class period to work on that, and if you have any questions about any of it, we can go over it tomorrow.